resources. For that, we are going to use this agenda. So we are talking about internet. So we are going to explain some key internet elements. Internet is big. We have a lot of elements on the internet, but I'm going to talk about some of the key elements that compose the internet that make it work. And I will end with how those internet resource numbers are managed worldwide in Africa. Okay, now can you guys hear me? Can you see what I'm sharing?
Yes, we can. For both.
Okay, all right. So now let's talk about the internet, some of the elements of the internet. The first thing is the definition of the internet. So I know that you guys started yesterday. So can someone tell me quickly what is the internet from what you guys learned since yesterday? Very quickly. Hello, can you give the mic to somebody in the room to tell what is the internet?
Anyone?
Can I try by one word?
Yes.
A medium of communication worldwide.
Yes. Who wants to say something else?
So you still want me to say something? Okay. So the internet is the network of networks, and it connects different ISNs, autonomous systems, like the network of different entities like universities, governments, and yeah.
Okay, thank you. So internet is the network of networks. So this is the definition that we have of the internet. And so you can see each of those dots represent a given network or a given autonomous system. And this network is connected to this one connected to this one connected to this one, and this one connected to this one, etc., etc. So this is how we created the internet, many networks connected to each other. So the question that we can ask is how does this network connect? This network here in Africa connect to this other network here in Russia? Or how can this network here in Russia connect to this other network here in Austria? So this the role of one of the key elements of the internet that we are calling the internet backbone. So this is the current internet backbone. So you remember in the West, we have some of those cables that were cut in some months ago, and we realized that it was very complicated for people in the West to connect to other people in the world. So this one of the key piece of the internet, the backbone, it's extremely important. As you can see, we have a lot of those cables, connecting the different region of the world. And you can see that in Europe and in America, we have a lot of cables. We can guess why we have so much cable between Europe and America compared to Africa and Europe, Africa or America, where we have very few. So who wants to try? Why do we have so more connectivity, so more links between Europe and America? Why?
Okay, I will give it a try.
Okay.
Maybe it's because the internet originated from the US.
Not really.
Okay, another one.
Yes, who wants to try? Who else wants to try?
Okay.
So let me ask you. What is the need of those cables? What is the use of those cables?
That's to provide access to the internet.
Yeah, that's to connect different regions. Okay.
Yeah.
So we have Regina on the online. You can unmute yourself and
is it in terms of traffic? Where the demand is more higher? Maybe service providers and
okay. Okay, thank you. You are coming closer. So just imagine that between Accra and Kumasi, we have, let's say, 2 cars that are using the roads per day. Okay, and between Accra and Abidjan, we have like 1,000 cars using the road. So what is going to happen? The government may create a lot of or larger road between Accra and Abidjan because they realize that per day we have 1,000 cars compared to Accra and Kumasi where we are only 2 or 5 cars per day. So see these intensities, this number of cable in terms of traffic. You see the size of the traffic that are passing through those 2 regions. So this is to tell us that they are exchanging a lot of information between Europe and America compared to Africa, where there is nothing to take. Because most of the content that we have in Africa, we put them in Europe, we store them in America, etc., etc. So this is why they don't have that much. We have nothing to share. This is the reason why they say, okay, why build a lot of cables when there is nothing to take there? So this is the reason why we have very few cables connecting Africa to the rest of the world. If we have creating a lot of content, they realize that, okay, to get this content, we need to create more cables, we need to connect more to the continent, then we are going to reach this level. So it's because of the traffic of data that is crossing, that is passing between Europe and America and vice versa. So this is the first element. So without backbone, we can't have internet. So all those regions can be connected without the internet backbone. The second point is that the question that we may have is, what are those organizations that are creating those backbone, these fibers? So they are called tier 1. So these are the internet service providers. So they are called tier 1. So each time you heard tier 1, you know that those are the big ones, the big organizations that are creating those fibers and connecting all the region. We also have the tier 2, and tier 2 they have agreement with tier 1, and they are selling internet connectivity to tier 3. So tier 3 are most of the time the internet service providers that we have in our countries. We have MTN, Glo, etc., etc. So those are the tier 1 or tier 3 operators. And the tier 1 and the tier 2 are the ones selling bandwidth to the others. So this is what they are calling them, bandwidth providers. So this is how we, those organizations are operating. Now, what are the tier 1 transit operators? Here I put some names. We have AT&T, we have CenturyLink, Deutsche Telekom Global Carrier, we have Orange Open Transit, Liberty Global, PCCW Global, Tata Communications. So those are some tier 1. So those are the big ones that are creating, that are building the internet backbone. And some of the key elements that characterize them is the fact that they are owning internet, they're owning portion of the internet, and they don't pay to connect the rest of the world. So if I'm connecting, let's say Europe to Africa, and I have my colleague who wants to come to Africa, but he doesn't have connectivity, I'm going to share my traffic. I'm going to allow him to pass through my network to my fiber to connect Africa. And at the same time, I'm going to pass through his fiber to connect Europe or to connect America. So this is what we are calling the peering. So there is no peering charge between them. So they are just using exchanging traffic for free, and they are giving access among themselves to the entire internet. And here there is the big internet governance issue that we used to discuss. Sometime people used to discuss about it. There's no authority to dictate rules there. Like we have regulator in telecom, we have regulator in newspaper, etc., regulator in television and so on. But in the tier at the tier 1 level, we don't have any body, we don't have any organization that regulates the sector. So this can be a problem because people say that they are owning the internet. So what's going to happen if they decide to stop, or if they decide to cut, if they decide to remove? So questions are there. So what's going to happen? Can we sue them? Can we freeze it? So yeah, it's one of the questions that people we may ask when we're talking about internet governance. Now for the tier 2 and tier 3, they are paying for everything. Most of the time, as I just explained, tier 2 are paying bandwidth to tier 1, and they are selling them to tier 3. And we have the possibility to tier 3 to go straight and pay bandwidth to tier 1 as well. So we have different level of peering that we can, set up according to your internal policy. If you want to go straight to tier 1, or if you want to use tier 2 and then go to tier 1, depends. And all those charges are borne by the customers. So this is why internet is not free, because one has to pay to connect to the global internet, and one has to pay devices, one has to pay staff to maintain the device, etc., etc., etc. And this is why we have to pay, okay, to get access to the internet. So this is the first element that I wanted to talk about. The second element is the protocol suite. We decide that we are going to all use internet. So we are using internet. This means that you have to decide what are the standards that we're going to use while exchanging data on the internet. It's the same thing that we are doing now. If I'm start speaking French, we are going to have problem because we are supposed to do it in English. We decide that this is a Ghana conference and the language is going to be English. So this is the standard. So if you want to come to this, if you want to be a presenter or speaker, you must do it in English. If you do it in French or in Chinese, you are going to be, it's not going to work. So this is what we are calling standard. We need to set up standard. We need to set a protocol that we say, hey, we are going to use those rules to use this internet that everybody wants to connect to. And we have organizations that are working to create standards that we are going to use on the internet. So we have ITF, and the ITF is one of the popular one on the IP sector. We have IEEE, we have ITU, and we have many other organizations that are working to create standards that are basically rules that we are using on the internet. So all those things that we know, DHCP, DNS, FTTP, HTTP, IMAP, LDAP, etc., etc., TCP, UDP, STP, IPv4, IPv6, IPv6, etc., etc. All those are standards. Those are protocols that the community said that, okay, we want to use IPv6. This is how we are going to use it. We want to use IPv4. This is how we are going to use it, etc., etc. So this is the second part of the internet, the protocol suite that is needed to be able to communicate using the same system. The last part of the key element that I wanted to talk to you are the resource numbers. So here are the autonomous system numbers, as one of the participants just explained. It's represent an autonomous system number. It's devices that are implementing the same routing policy. So let's say Orange, MTN, or maybe University of Accra, or if they want to have their own identity on the internet, they must have their own autonomous system number and apply a single routing policy for them. So this is how it's presented here. So each network connected on the internet, you remember the first picture with those different black dots? Those dots must have an autonomous system number, because this autonomous system number will identify those networks on the internet. So this is the first thing. And we used to have 16-bit ASN. Now we have 32-bit ASN, because the 16-bit have been exhausted. So this is why we are using down the 32-bit ASN. And as I said, each network connected to the internet must be identified with this autonomous system number. Now, behind the network, inside the network, we have connected devices. So as you can see, we have router, we have switches, we have computers, we have we have tablet, we have mobile phone, we have, each of those devices need to be connected to wants to get connected to the internet. And to make it possible, they must be identified. Each device connected to the internet has to be identified with an IPv4 address and or an IPv6 address. So these are what we are calling the internet resource numbers. We have autonomous system numbers to identify networks, and we have IPv4 or IPv6 addresses that are there to identify devices. So my phone, your fridge, your Your AC that's connected to the internet has a public IP address to connect to the internet. This is it. Now, the last piece is the DNS system. As you can see, those IP addresses that are there to identify all those devices are not that easy to remember. If you take AFRINIC.net, for instance, this is the IPv4 address, and this is the IPv6 address. So those are there to identify this website on the internet, okay? So for us, as we are human, it's very easy to remember name. This is why we have the phone book, even on our phone. We have a lot of friends. We remember the name, but we can't remember the phone number. So this is the same mechanism. This is why the DNS have been created to make it easier to map IP to name. And today, to that example, DNS is play a critical role on the internet because, as I just said, machines understand numbers, but human understand or remember easily remember names. So this was critical. If DNS is down on the internet, it's going to be a big problem. This means that we must remember all those names to connect to Facebook. I'm not sure we can remember 2803:2883:F blah 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 colon. It's very complicated to remember. So this is why the DNS is playing a key role on the internet. But again, a DNS is just a phone book. So with no IP, we can't have internet. If we don't have internet backbone, we can't connect networks. You can have your own thing in your home, you can have your own thing in your country, but unfortunately, Ghana cannot connect to France, Ghana cannot connect to London, Ghana, et cetera, et cetera. So the backbone is very important. And because we are using the same antenna, we must speak the same language. This is why we have the standards to be able to talk to each other. Now, this is how internet reaches at home. So the first thing is the customer. So we are here, we are at home, okay? So the internet service provider is going to send us what we are calling the CPE. So this small router that they configure and you put at your premise. So this small device is called the CPE, and this part is called the access network. So here is the access network. So in the access network, we have technologies that like 4G, 3G, and FTTH, etc. I'm in the conference, etc. So this is where we are connecting to the network of the mobile operator of the internet service provider. This is how we are doing it. And when we are here, when we are connected to the internet service provider over fiber to the home or over 4G, 3G, the access network technologies that we know, then we pass through the core network of the operator. And we are in the core network of the operator. And remember that we want to connect to the internet. To connect to the internet, we can connect via tier 1 POP. So we have our spoke router connected to a tier 1 POP. And this tier 1 POP is connecting us to the internet. Or we can use another technique where the operator with other operator in the same country have decided to create a tier 2 or an internet exchange point, an XP. And go to the another POP, tier 1 POP, and connect to the internet. So this is basically how we get internet at home. So what is going to happen is that the internet service provider is going to put money to build this, the network, to put money to connect. This is what we are calling the last mile, to put money to set up this network, put money to connect to the POP 1, the tier 1 POP, put money to create an XP, put money and then to connect. So these all those costs that at the end of the day we are paying. So this is how we are getting internet at home. So as you can see, if you don't have a tier 1 POP, we are going to be isolated in our country. You see, so we must have a tier 1 POP to get out to our country and to go connect the other countries. So this is what I want to say about the internet. And now let's talk about the IP numbers and how they are managed. We say that IP numbers are key on the internet because with no IP, no internet. You don't have IP, you cannot connect your device. You don't have autonomous system number, you cannot connect your network to the internet. So those elements are very important. How are those elements managed? So we have what we are calling regional internet registries. There are 5, and they have 3 key functions. The first one is to manage and allocate IP numbers, autonomous system numbers, IPv4, IPv6 addresses. The second one is to manage those IPs to ensure that they are unique worldwide. And the third one is to coordinate resource policy regionally. So they are running those 3 key functions, and next to those functions, they have other functions that are running as well. Like we have capacity building, we have community development, we have etc. We have services today to our community. So this is it. So I hope that you got these 3 key functions: attribution and assignment of IP numbers, management of IP numbers by maintaining a database where they ensure that IPs are unique. The last one is to coordinate resource policy. Now, how those IP are managed? So we have those IP are managed over the IANA function, Internet Assigned Number Authority. So behind this function, we have the block of IP numbers are being allocated to regional internet registry here. Okay. And when we go to IP block, IPv4 block, IPv6 block, and autonomous system number block, we are now in each region, and each region is, start now allocate or assign those IP to its members. So let's focus on AFRINIC in our so we assign or reallocate depending on the policy they have internally, and we do also assignment for end user. We also assignment for end user. So this is basically how IPs are distributed, and in the region, in Africa region, in the other region as well. As you can see that all the areas are there, and we are issuing and allocating the IPs to members. And we have to be an organization to be eligible to get IP. You can't be individual and say that you want IP. You must be an organization. So this is why only organization can get resources from the different areas that we have in the world. Here is the question that I wanted to ask, so that you have a big picture of how many IPs do you guys need to connect your devices to the internet in Ghana, for instance. So let's say that you have, let's say, 5 devices connected at home. If you and your wife, and if you want to put, we are in Africa, so we can have your nephew, your cousin, etc., in your home. So you're going to be close to 10 devices connected per home. Okay. Now, if we have 10 devices connected per home, now let's see how many homes do we have in Ghana, and we do the math. And you are going to see that we need millions of IPv4 address to connect all the devices in Ghana. Now, let's see. According to Statistica in 2018, we were 22 billion of connected devices. And in 2030, you are going to be 5 billion or more connected to the devices. Now, IPv4 and IPv6. IPv4 is 4 billion IPs, when IPv6 is 3.4 trillion of available IP. So now we are talking about connected devices. Today, what are the IPv4 addresses that we have in the world? So out of the 5 areas, RIPE-NCC has exhausted. It's one: LACNIC, AFRINIC, and AFRINIC are the last 2 areas that are still IPv4 available. Okay. So now we are talking about IPv4 exhaustion. As you can see, we have 4 billion of available IP, but in 2018, we were over 20 billion of connected devices. So you can see that you are using technologies that allow us to share IPs and so on. So this is why it's very important for us to think about the next step. Now, still on this IPv4 exhaustion, These the IPv4 addresses that we have received at AFRINIC. So we got those different /8, and we have several IPv4 address that we have received at AFRINIC. And today we have exhausted almost the IPv4 addresses. We have exhausted the IPv4 addresses, as you can see. And I'm going to give you like what we are having today at AFRINIC. We have 1,096,704 IPv4 addresses. These for the entire region, Africa and Indian Ocean. So you can see that when we are talking about IPv4, we have almost completely exhausted the IPv4. And this is why it's important for us to talk about IPv6. So IPv4 have been there for a while. And it was very useful. It was there for a while. And now it's time for us to deploy IPv6. And I'm going to give you some statistics and the reason why we must deploy IPv6. These are the IPv6 addresses that we have issued since we started operation, /32 IPv6 addresses. As you can see, we have 10,000 /32 that have been assigned. And the good thing is that year after year, we have many, network that are connected over IPv6. And this is very important. As you can see in 24, we have issued more. We are in July, and you see that we have issued more IPv6 compared to the 2023, etc., etc. So this to tell you that today many networks are starting connecting advertising prefix, IPv6 prefix, and connected devices over IPv6 because they know that IPv4 cannot, support the evolution of the internet in Africa. Now, this is the IPv6 adoption worldwide. As you can see, we have, AFRINIC is like, Africa is lagging behind. I will say as usual, but I hope that we are going to bridge the gap very soon. And so you can see, but I'm happy to tell you that year after year, we have many networks that are connected to the internet. And I was surprised when I was getting those statistics to see that countries like Mali, countries like Niger, that you said, no, those guys cannot do it, but are doing pretty well in the region. So now let's focus on the region. So you can see, IPv6 adoption, 50% Mauritania, 57% in Mali, Burkina Faso 36. We are in the West, so those guys are no more in ECOWAS. Okay, but they are trying. Ghana, we have 27% of adoption. Cote d'Ivoire 36. We have, as you can see, Capo Verde. All our countries in Africa are moving. They are doing something regarding IPv6. Something is happening. Something is happening. Is very interesting to see that, they know that the future of the internet cannot be IPv4, but IPv6. Now, why is it important for us to think of IPv6? And this is almost my last slide. The first thing is that the internet penetration rate is growing, but it's still around 40% in Africa. If we want to connect the next 20% of Africans to the internet, if we want to be close to 60%, this means that we are going to use more devices on the internet, more network connected to the internet. And as you see, this can't be done over IPv4 because it's only 1 million of IPv4 for the entire Africa. And we are not going to issue, it's like gold. So Africa is not going to issue IPv4 like this. You have to, prove that you're going to use it for the next 3 months. You have, it's a lot of barriers, and those barriers have been put in place by the community over the resource policy development. So if you're not happy, you can come and try to customize them. And Africa is also a huge building site. We have a lot of new construction going around in Africa. We have mobile operators that are starting operation in Africa. They are starting with LTE or with 5G and 5T FTTH. And those are technologies that are using a lot of IPs, and they can't start deploying with IPv4 because they won't have enough IPv4 to connect the customers. We are talking about cyber security in Africa, and when we have a cyber attack, the first thing we want to know is where this attack is coming from, and to know that we need to find the IP address, the source of the packet that we have received, and to find because we are using a lot of sharing technology, we can realize that this IP address was used by, let's say, 200 persons for the last 2 days. So it's making it very complicated to find who did what, this particular day at this particular time. This is where IPv6 is going to be useful, because we can have one IP per device that we have at home, at the office, at the university. Is going to be public IP that we are going to use on the internet, and this is going to reduce the risk of hiding behind, one IP doing bad things for that will impact everybody. We also are technology consumer. We hardly create in Africa. It's very sad, but this is the truth. We are using technologies. We are using social media from Europe, from America, even though you can create one in Africa. We don't do that. We prefer to use, So when you are a technology consumer, we have to be up to date. As you realize the internet, the IPv6 adoption, you can see that America and Europe and Asia, they are completely green. So if you want to be able to access all those information that are available in America and Europe and Asia, we have to be also ready and start migrating to IPv6. IPv4 was seen as the American protocol. Okay, we said, okay, it's very old, this American stuff, but we can't say the same thing for IPv6 because IPv6 has been created in 1998. So we can't say that it's something old where most of us were there already when this protocol was released. So we still have way of improvement, but a lot of things, but a lot of work possible around IPv6. We don't have enough time to discuss, but I have many things to say about project now, how to use IPv6 now day to day, and so on. But because of time, I'm going to stop here, and we must get ready when the giants will stop maintaining the IPv4 stack, because what we have today is like the giant Google, Facebook, Meta, if you want, and those big boy, they're maintaining 2 stacks, IPv6 and IPv4, and they are paying people to maintain the IPv4 stack. But when you go back, when you look at the big picture of the internet, the IPv6 adoption, you see that they are almost ready, and most of their customers are not in Africa. The big, chunk of the customer that they have in America and Europe and in Asia, and they are ready. So they can decide one day to stop the IPv4 stack. And what is going to happen if they stop the stack? We are going to be disconnected from those big ones. So this is why it's important for us to get ready. I hope this was informative for you. It was a bit fast, but I hope you managed to get some points. So I discussed about the internet element. I said we have the backbone that is connecting the network, the regions, and we have the protocol suites that are the rules that we use to communicate on the same internet. We have the IP numbers that are very important because they identify each network and each device connected on the internet. And we have the DNS that is playing a key role, like a phone book, to help us to connect all those devices, all those network, all those services. And the second part was how those IPs were managed. I said that we have 5 regional Internet registries, and that they have 3 core functions: assign those IP, ensure that those IP are unique, and coordinate the regional resource policy. And after that, I explained that we have exhausted all the IPv4 available, And in Africa, for instance, we have only 1 million IPv4 available. So this is why it's time for us to continue to deploy, to adopt IPv6. I would like to thank you for your time. And if you have questions, I'm ready to take them. Thank you. Over to you.
Thank you so much. We are grateful for your time. And there's a question for you, so kindly hold on.
Yes, hi everyone. So I'm Frank Anati, and I would like to ask this question. I asked the quest to improve connectivity with IPv6. I'm sure you have certification, IPv6 certified course on AFRINIC. I've taken that course and I wrote the certification, but I say it to be more difficult than CCNA itself. So if you could revise the course, because deploying IPv6 is much simpler. So I understand I can deploy it, but getting the certification itself is quite difficult. So if you could relook at that, that will help so that you can get more engineers certified so to help deploy more IPv6 within Africa. Thank you.
Okay, thank you. So it's mostly a comment. So what we have to help the community to get certified is also to create advanced courses. So we can organize advanced courses, like 2 weeks to your exam. We come in Ghana if you are a good number of people, and you can take care of the accommodation and transportation of the trainer. We come, we train you, we prepare you, and you can take the exam. So this is how we manage to help our community members. But yeah, I've taken note of your feedback, by the way. Thank you.
Bryce, thanks
Yeah.
very much. So Frank was actually the one who just made a comment, was actually the best in the IPv6 exam that you took. So he took the first position.
Raymond,
He
yeah?
didn't want to say it, so I want to remind you that he's the one who just spoke.
All right, all right. Well done, guy. Well done.
Okay,
All right, next question.
I go.
Go.
Okay.
Yeah.
So, hello, Mr. Bryce. This is Berry Ashile from Benin. It's just a curious question, though. So, most of the time when we are talking about the exhaustion of IPv4, we just talk about the fact that it's among the, I think, five RRs. We just mentioned AFRINIC, but during your presentation, you mentioned AFRINIC as well. So I'm just curious to know, why don't people talk about AFRINIC, but they always mention AFRINIC?
Okay, that's a good question. I wanted to make this clarification. So AFRINIC has what we are calling AFRINIC Foundation. Okay, so AFRINIC as an area has exhausted all its IPv4 blocks, but a community member in the AFRINIC region said that, okay, I'm giving this IPv4 block for you to use the money to sustain the AFRINIC Foundation. So it was like a private contribution to AFRINIC Foundation. So as an area, AFRINIC has exhausted its IPv4 block. This IPv4 block belongs to AFRINIC community, and it has been given to AFRINIC Foundation by a community member. Is that clear now?
Is that clear? Okay, so he's not so clear, so Bryce.
Okay, let me repeat.
Yeah.
AFRINIC has, let's say, okay, let me take an example of AFRINIC. AFRINIC currently has 1 million of IPv4 address, right? So this is the block with the current, IPs that we have. Let's say that in 4 months, we exhausted all this 1 million. And let's say one community member like MTN Ghana say, you know what? Because we want to help AFRINIC give many, sponsorship to country to organize maybe the IGF, I'm going to give a /16 to AFRINIC. This /16 is going to be used for AFRINIC Foundation and capacity building. Okay, so it belongs to a community member, but these community members say, okay, I'm going to give this block to AFRINIC for AFRINIC to make money out of it to support its community engagement. Is that clear now?
It's clear now. Thank you.
Okay, so that was the
Okay,
case
so-
of AFRINIC. It
Okay,
has
so
been given
we'll take
to
the last
AFRINIC
question.
Yeah.
Yeah, then we are done.
Hello, sir.
Yeah. Hi.
Thank you for your
Okay.
presentation.
Right.
I want to ask, with the emerging technology like the satellite provision of internet, like Starlink, has the community developed any policies around to govern that or to support that in the region? Thank you.
Okay, this is a very good question, by the way. Well, it's, Starlink, it's like an internet service provider, and it wants to operate in a given country. So it's going to fall under this regulation of this country. It's not like a community is going to develop something. The community is developing things related to IP numbers and autonomous system numbers and how we are going to manage the resources to run internet in Africa. But when it's come to provide internet to end user, this operator has to fall under the regulation. So in Ghana, for instance, Starlink is there. Starlink must respect the regulation, the rules that are in place that the regulator put in place. Same thing like in Ghana, the same way like MTN or Glo, et cetera, are doing in Ghana. Is that clear? You see the difference? Is that clear?
Yeah. That's clear. That's clear.
Okay.
All right. So Bryce, we are very grateful for your time. Thank
Yes,
you
thank you
so
very much.
much. Yes, thank you. Thank you.
Yes.
All right. So please, can we give him a round of applause?